So what can you tell me about that periodic table that we see either in front of you? I would advise getting that out, and then maybe a calculator if you think you need one. But what can you tell me about that periodic table that we've learned so far? Okay, there's different groups. Either looking at Bob over there on the west wall or the table that you see in front of you that was handed to you. Okay, what can you tell me? There's in groups, that's right. What else can you tell me? When you are looking at each individual box, each element's individual box, what information is provided in there? Atomic mass. Okay, atomic mass are which two subatomic particles? Not electrons. Protons and neutrons. Now, one of the things you're going to find out as we continue further and further into these science curriculums, when we start reviewing these concepts day after day, it's your opportunity to catch them. And should you be the type of individual that is just blocking that out, we all have our bad days. I have them, you have them. Heck, Mr. Hammer has bad days too, okay? But when they start maybe mounting up, maybe it's time to say, gosh, I need some extra help with this, okay? So you said atomic mass, that's the protons and neutrons, that's correct. What other subatomic particle is there? You mentioned it, but it's not the electron, okay? So what else can you tell me inside of each individual box? Just pick a number, any number. Okay, so what can you tell me about element number 4? What is it? It's beryllium. It's an alkaline earth metal. What else can you tell me about beryllium? It's in the S block. Its atomic mass is what, 7? No, it's close to 8. Okay, so 9. So how many of you are perhaps listening to this and saying, I have no idea what's going on? Left outside, we good so far? Left middle, middle, right middle, okay, right outside, right outside, right outside, right outside. Okay, so with that, we'll continue with where we had left off. Learning about this periodic table. Now, as we've said before, there's maybe a few reasons why we as a faculty or in this classroom would say that it's important. One, when are you possibly going to be using this again? Some of you people, you can say, I'm not. When will you possibly be seeing this again? In 2 years, okay, take this class, not this class again, but use this information in general chemistry, okay? And this information is required for you to know according to the South Dakota Science Content Standards. That's why we go over this. And another reason is maybe this is helping you on your step test, ACT tests. Okay, so it is all relevant information. For instance, when you understand a lot of these different types of concepts that we go over in this class, you can maybe make sense of what we can do. I can't remember where. I want to say it was tanker. Semi-truck tanker that collided with another semi-truck and 2 cars or 3 cars, and so far within that pileup out of whether Interstate 80 or I don't know where this was, but 7 individuals have already been unfortunately parted this earth from that accident. Okay, so when we start talking about some of these concepts, if it is, we say gas or gasoline, that's a pretty vague term. Yes, I'm going to 34 stop to get gas, okay? Yes, it's just commonplace to say I need gas, but the scientific name, for instance, of course, is octane. Okay, so when you pull up to a gas pump, for instance, what do you notice on there? There's a little yellow sticker that has a number on there. Okay, what is that? It's an octane rating. Okay, and some of them you just might pull up, and if you see a set of fuel pumps where you see 87, 89, 91, which one of them is the most expensive? 91, because what that means is that gasoline is 91% octane, okay, that has, and then it is also 9% heptane. Get into that further down the line when we're dealing with organic chemistry. So what happens is if you're dealing with working on a gas tank, now this maybe defies all logic, okay? Now, and I could be totally wrong. Some of you might be thinking, we discussed this in class, our science teacher doesn't know a thing. Gosh, he's an idiot. Okay, maybe yes, maybe no. But for instance, your pops, does he ever work on something around the gas tank where he might have to cut something out of there? That I don't know why you would know that, but let's say for argument's sake that you have to work on that. What two things do you probably need to do when you're working around that gas tank? Well, three things. One, you could either empty it. Two, maybe even just take the gas tank off. And three, probably one that you wouldn't think of is kind of, geez, that defies all logic. You might take that tank and do what? Fill it. Fill the tank. Why might you do that? You're close. You're not leaving any fumes. Okay? So if there's no fumes, there's really nothing to combust. You know, although there's lots of different arguments that you could do. That if you had a pail of gasoline, I wouldn't recommend doing this, but scientifically it's possible. Strike a match, throw it in that gasoline, it just goes out because there's not enough fumes for that to combust. Except that's nothing that I would suggest that you do, but that's the logic that we would be basing this off. And hopefully I'm not totally wrong with that, but again, we're trying to make sense of the natural world that we see around us. And when we're looking at atoms at this particular level, Star Trek people, one of the things that I liked growing up, played sports, was in the band, was a moviegoer, did many things just to make a really broaden your horizons. What do we know about Star Trek that they do? The thing is, they say, okay, beam me up. Do we know what we're talking about there? When we say beam me up, what you're doing is taking, you've been answering all the questions. Who can we pick on? Okay, so what we could do, and this isn't that far off, it's pretty scientifically accurate, we will take a machine that copies everything about Haley, all down to the subatomic level. That is then copied, okay, Haley, where do we want to go in the world? Okay, so if there's what had copied you here in South Dakota and that same type of machine that can reassemble that copy down in China, all the way down to the subatomic level, we will take Haley from South Dakota and transport you to China, do some dealing with President Xi. Do you know who President Xi is? Of course, President of China. Get some of these trade deals going. So your friend here is sending you to say, come on here, President Xi. Come on, buy some of our goods. See? But what happens is the copy of Haley here in South Dakota is totally destroyed. There is no more Haley. We keep your fingers crossed that whatever it is that copies you in China is an exact copy. Because if it isn't, well then, Haley's gone for good. Okay? And that's what we call quantum mechanics. And that's something that some of you will be discussing in general chemistry class. It's all the way down to the subatomic particle that makes up everything in this universe, including that of people. Okay, so as we look at this, okay, the nucleus of an atom, it's a small positive portion of that atom. It used to be theorized that the atom had the proton in it, the neutron, and the electron all in the same area. Of course, that's incorrect because we know and illustrated yesterday that the electron does what around the nucleus? It circles it in a structure called the what cloud? The electron cloud. Okay, so the atomic components, okay? On the periodic table, the number of protons is given by what number? Atomic mass or atomic number? Atomic number. So when we said 4 earlier, the atomic number for beryllium is 4. That's what we use to identify that element. Okay? So we'll be putting some of this information here to use. That's what all these numbers are over here on the right-hand side. So we'll start talking about isotopes. That's one of your vocab terms as well. Yes, carbon. And chlorine. Gold. On the periodic table, it's silver and gold are in the same column, and silver is so friendly. You know why that is? Because it just looks at gold and says AU. Just waves that says AU. AU. You people can either it just wasn't that funny, or you can laugh and smile. You're not going to break your face. Okay? It's not cool to laugh. If you laugh, that means you're not being cool. It means you think that teachers are cool and they're not cool. Maybe if I rode my motorcycle to school today, that would be cool in more ways than one. Yeah, I think I'd freeze my fingers off. And I have ridden before where once I arrived at my destination in a different school I taught in, I couldn't feel my legs from my hips down. It's one of them times to where a person gets so excited, like some of you who maybe ride snowmobile, you can't wait till that first snowfall. Well, this was in March, and looking at the you have to decide, well, if the temperature is 32 degrees or more, I think I'll go ahead and ride. Okay? So I look at the outside temperature. Sure enough, I think it's about 33. I arrive at the destination, turn the radio on. This is the same day I couldn't feel my legs. Turn on the radio, and right now in Sioux Falls, we got 28 degrees. So it was in the 20s when I rode down there. Don't do that, people. Okay? Is that cool? Don't ride a motorcycle to school. So, Anyway, moving on. So we had discussed it. We read this in class yesterday. Okay, Democritus and Aristotle thought that all this matter, all these are in the same general area: the protons, the neutrons, the electrons. As you're reading this and writing and thinking, there's just really no rational reason why would someone want to know this? Why would we want to learn this? Why would we want to know it? Why would we want to learn it? How would we ever apply it? Well, some of these concepts would apply to a field of what we call biochemistry. Okay, and we'll talk about that here in just a moment. So if perhaps you might know a family member who says, "Gosh, I'm going to go on a diet." Has anyone ever heard of is it ketose diet? Maybe. Say that again. It's called the ketone diet. Okay. Oh, keto. Okay. So there's no reason why you would know that, but for those of you who may go on to take the pinnacle of science classes, that being organic and biochemistry. Now, if I was to that in 3 years, this is what I would expect. I could be wrong. 1, 2, 3, 4. I don't know. 5. You 5. Okay? So let's just see how accurate this is. If you could look into the future, what do you want to be doing 10 years from now? And maybe you don't know, and that's a valid answer. If you don't mind sharing. Okay? Okay? I didn't hear you. Okay? So I was right. I was right. Maybe. I'm going to say I'm right because I'm just going to be that type of person. I'm right. I'm still going to go out on a limb and say I'm right. Come on, we're Minnesota fans. We got to stick together, right? We got this to look forward to because the Vikings are done, right? Target Field. Eventually, you need to go back up there and watch the Twins play. Us Minnesota fans got to stick together. It's not embarrassing. We can say, yes, I'm a Minnesota fan. See? All right. So, now, for those of you who go on to take that, what do we know? What's diabetes? It is a disease. It's what? Say that again. Okay? So, what's maybe not functioning correctly? No. Not the liver, not the appendix. No. Starts with a P. Pancreas. Okay? So what happens is, for those of you who take biochemistry, we classify sugars into 2 types. There's aldose sugars like glucose, maltose. You're all familiar with those. Then there's also ketose sugars, and that's what you're talking about with that keto diet. Okay? So what happens is your body metabolizes these different because of how these are different structurally. Okay? And sometimes it's just as simple as flipping one molecule up like this changes the complexity of that compound. Okay? So that's why it's important for especially some of you, which I'm still going to say 1, 2, 3, 4, and 5, that you try to maintain and understand what it is we're going over. Should I have said 6? Do I hear 7? Do I hear 7? Come on, get in on this auction. 7, 7, 7, 7, 7, 7. Do I hear 8? 8, 8. Okay. Okay, so we're up to double digits then. Very good. Okay. So, okay, we want to go over this, okay? Then we're going to start applying some of that information that we've been going over these last couple of days. So if I had left you out thinking I like science, my apologies. So we'll see. I had to have left some Minnesota fans out. We can't be the only 3 smart people in here. Only 4, 5 smart people. Okay. Okay. All right. Does everyone have this information that wants it? Okay, how about now? Okay. Okay, so as we continue, all right. So as we look at this, okay, these 4 elements here, okay, especially these top 2. C, of course, is carbon, okay? So which 2 of these numbers are the same? Of course, it's the 6. With that, that must be which number for carbon? The atomic mass or the atomic number? Atomic number, okay? So, why is that atomic number so important? Close. How many what there are? Can be. Protons. Okay. So, for carbon 12, okay, we know, okay, this 6, this identifies the element and tells you how many protons there are. Okay? Then you said electrons earlier, which is true if it's neutral. Okay? So if we're saying this carbon is neutral, how many electrons would it have? 6. Okay? Now, how many neutrons does carbon-12 have? Because if this is the atomic mass, which we're saying that it is, okay, yesterday we solved for the number of neutrons by saying protons plus neutrons equals atomic mass, okay? So if we have 12 here, okay, and we put 6 in here, how do we solve for n? You subtract these two, okay? In other words, 6 plus n equals 12. We subtract each side by 6. They're gone. Neutrons equals 6. Went through that really, really fast. Is anybody lost? Okay? So then, what do we see as the difference between carbon-12 and carbon-14 then, other than the number of 12 and 14? Which one of these numbers is going to change? The neutrons is correct. Was that just a guess? Okay. So how many neutrons does carbon-14 have? And how did we arrive at 8? 14 minus 6 would give you 8. Okay? So carbon-12 has 6 neutrons. Carbon-14 has 8. There's also carbon-10 would have how many neutrons then? 4. Okay? If you are following this logic, you're well on your way to understanding what subatomic particles are as in regards how they fit in with an element. Okay, so for chlorine, okay, what can you tell me about chlorine here? It has 17 protons. How many electrons does it have? How many electrons does it have? 17. Okay? And then how many neutrons does it have? How many neutrons? 18. Okay? What happens when we take 17 from 35? We get what? 18. Okay? Are we catching on to, again, this is kind of like a pattern here. So now, finally, what can you tell me about gold? 79 protons. 79 electrons. I think there's 118. Okay? Okay. So subatomic particles. Left outside. Are we good? Left middle. Middle. Right middle. Right outside. Okay? So if you're one of these that's doing this, what did we say that you probably better start doing? Asking questions or asking for help. Because I'm willing to bet there's some that are saying yes, that it's actually no. Okay? Because just like when tomorrow hits, let's say, I just happen to look at yourself, so I'm going to pick on you. Okay? So, Seattle wins the toss. So then Dallas has to pick. Are they going to kick or receive? Because Seattle said, well, we're going to defer. Okay? Defer till the second half. So now Dallas has to kick off, they need to receive. They don't want to kick off or else they're going to lose the ball twice. So they're going to receive. Okay? So what happens is Seattle kicks off to Dallas, and the kick receiver, it's coming down. He loses it in the lights. It hits him and bounces right into the hands of Seattle player. Right into the end zone they go. It's 6-0 already, and there's 2 seconds that ran off the clock. Okay? That would not be very good, because now Dallas is starting behind already. And especially in the playoffs, is it easy to catch up when you're behind? Now, if this was maybe, not to pick on someone like San Francisco or Tampa Bay or some of these teams that maybe went 2 and whatever, you can probably catch up to them. But if you fall behind Seattle, if you are falling behind now, you're going to really make it hard on yourself trying to get caught up. But that is a personal choice that you would be making. Okay, so now's the time to make sure you can stay caught up. Okay, so I want you to think about, we're going to try to keep these elements quite small. So someone pick a number between 1 and 10. 7. That's what I heard first. So element number 7 is who? Nitrogen. It's nitrogen. So why did we say element number 7? Because 7 is what number? Can be. I've heard that before too. 6 is so scared because 7, 8, 9. Yeah. You got a perplexed look on your face that like I don't get, so that's why we get it now, right? Okay. So why are we writing this little 7 here? It's the number of protons. Yes, it's also the number of neutrons, but don't fall into that trap. Okay? So now, the atomic mass is also 14. So yes, it is the number of neutrons. I get that. Okay? So now, what we want to do is, what's the electron cloud? It's where what's going to be found? Electrons in very specific what levels? Energy levels. Okay? Because we had looked at this diagram, okay, and according to yesterday, people were saying, yes, I get it, I understand. Okay, so what we're referring to here is this guy right here. We're talking about this model showing the electron cloud and why certain numbers of electrons are found in certain energy levels. Okay? Because, for instance, the third energy level can hold how many? Well, add these numbers together. 2, 6, and 10 gives you what? 18. The fourth energy level can hold 32. The reason for that is 14 plus 10 gives you 24. Okay? Plus 6 more gives you 30, and then 2 more, that's where you get 32 from. Okay? So, when we're talking about nitrogen here, inside this nucleus, okay, so this is where we're going to apply that slide rule. Okay? So these big numbers, the only difference between this slide rule and the one that you have is I don't have these little exponents up here. But remember from prior knowledge, okay, the first 2 rows is called the S block. And that can hold how many columns are in the S block? How many columns are in the S block? 2. Okay? That's where these exponents are coming from, because there's 2 columns in the S block. The P block, all the way over here, how many columns are in this P block? 6. So that's why you would see 6, 6, 6, 6, 6, 6. The D block holds how many? There's 10 columns in the D block, and then finally underneath here in the F block, there are how many columns? 14. Okay. So these big numbers are illustrating the energy level. Now some of you may be saying, I don't know what's going on yet. Well, this is the first time that we've seen this. You may have discussed this in earth science, yes? No? Okay. So what we're saying here, in the first energy level, okay, our very first energy level, we're in the S block, and the S block can hold how many? No. It can hold 2. Okay? So here they are. Because remember, how many electrons do we want to get to add up to 0? Because if there's 7 positive charges, how many negative charges do we need to get? We need to get up to 7. So we've got 2. How many more do we have to go? 5. Okay? So now here's another one of them coinky dinks. Okay? As you look at your table, or the one on the west wall here, what column is nitrogen in? No. Don't go by those numbers on that table. Okay? No. Okay, we had discussed this yesterday. Remember this diagram that we seen? We said we like this depiction because it has the S block here and the P block over here. Because that's why those two get added together. So this whole second energy level can hold how many? What's 2 plus 6? Remember talking about octagon yesterday? The stop, see? The top sign's got 8 sides to it. So the second energy level can hold 8. But what I want you to think about is either count on your table or look at this guy over here. Remember, see, lithium and beryllium is in the second block, or second energy level, excuse me, in the S block. So that's column 1, that's column 2. Okay? Then we go all the way over here to column 3, 4. So then nitrogen is in which column? 5. How many do we say we have left to go? 5. Do we see this pattern that's going to slowly start to emerge between all these different elements? Again, that's why it's a periodic function. It continues to repeat itself over and over. Okay, so this, we climbed up the top of that slide, we went down. Then you climb up to the top of this slide and go down. This is saying we need a new energy level. Okay? 2 for the S block. Then look at the P block, which holds, there's 6 columns in the P block. Who's lost already? Okay? So when you look at the P block, over here, right? This is the P block. Okay? Or you could establish this is the P block over here, right? Okay? What column is nitrogen in the P block? 3. Okay? Well, 1, 2, 3. Right there it is, in the third column. Okay? So, what happens when we add all them numbers together? We get 7. How many were we supposed to get? 7. So, this must be correct then. Now, this is the very first time that you've seen information like this. So, this reflection time, we've seen some of you be honest now, and if you're not being honest, you are not giving yourself any favor or doing yourself any favors. It's going to be like that scenario that could happen if you're falling behind. Your team in the playoffs here is falling behind. It is not easy to get caught up. So, this information, left outside, are we on the bus? Well, we just walked in. Left middle. And if you're going like this, you're telling me that you understand. Middle. Right middle. Right outside. Yes? Okay, good. We will continue with a lot of this next week. We might get into configurations, which is a linear depiction of this. If you did not understand this, we're going to go over it again and again just to make sure that we understand this. We'll pick up with this next week.